Okay, so now we're going to look at proportional relationships and how we can find them in real life situations. So the table below gives the cost to purchase different numbers of tickets for an event. Do the ratios in the table represent a proportional relationship? So recall that to find if a proportional relationship exists in a table, we need to compare the ratio of our y values to our x value for each set of x and y values in the table. And in this table, our x values are the number of tickets and our y values are the dollars. So when I compare the ratio for the first one, my y value is 5 and my x value is 1. For the second set of numbers, my y value is 10 and my x value is 2. For the third set of numbers, my y value is 15 and my x value is 3. And for the fourth set of numbers, my y value is 20 and my x value is 4. Step 2 says to simplify your proportions. So the ratio of 5 to 1 is already simplified. The ratio of 10 to 2 simplifies to 5 to 1. The ratio of 15 to 3 simplifies to 5 to 1. And the ratio for the 20 to 4 simplifies to 5 to 1. Because all of these are simplified to 5 to 1, then this is a proportional relationship, and our constant of proportionality is 5, or $5 for one ticket. Okay, now that I have a table where I have the number of tickets represented by the variable x and the cost in dollars represented by the variable y, I have an ordered pair x and y that I can now go and graph. So when I look at my graph, my x is the number of tickets, that's my independent variable, and my y-axis is the cost of tickets in dollars, and that's my dependent variable. So my first ordered pair is x is 1 and y is 5. So x is 1, y is 5. The second ordered pair, x is 2, y is 10. X is 2, y is 10. The third ordered pair is x is 3, y is 15. X is 3, y is 15. And the last one, x is 4 and y is 20. And if a graph is proportional, it will start at the point 0, 0, and it will be a straight line. And because my graph has fulfilled both of these conditions, this is a proportional relationship. If proportionality exists, we can determine the constant of proportionality for either the table or the graph. And remember that in our first example in the table, we found the unit rate, or the ratio of our y's to x's in the table, to simplify to 5 to 1, or $5 for one ticket. Not only is this our unit rate, but it's also K, our constant of proportionality. And from that, we can write the rule for this example, which would be our y is equal to 5x, where 5 is our unit rate, $5 for one ticket, times the number of tickets will tell us how much those tickets cost. And finally, putting it all together, we can find that constant of proportionality, or our unit rate, in our table, where it's $5 for one ticket, in our graph, where it's $5 for one ticket, or in our rule, where it's $5 for one ticket. I hope that this video has helped you to understand the constant of proportionality and finding proportionality as it exists in tables, graphs, and rules.